For part C, we need to find the size of the angle between the edge VC and the base of the pyramid ABCD. So the angle between a line and a plane is the angle between the line and its projection onto the plane. So what that means is imagine shining a light straight down from above this pyramid. The edge VC would cast a shadow onto the base, and that shadow is the line in blue there, XC. So the angle between the line and the plane is the angle between the line and its shadow. So in this case here, it's the angle between the red line VC and the blue line XC. So what we'll do, just to make this a little bit clearer, because when we have questions that involve 3D shapes, they're not always easy to picture. So I'll get up a 3D version of this pyramid here that we can rotate about, and then we can see that projection of VC onto the base of the pyramid. Okay, so here's the 3D version of the pyramid. So if we just rotate it about, so we're looking directly down on it, we can see that line VC. And if we were to shine a light directly down on this pyramid, like from this sort of angle, we can see the shadow cast of that line VC is that blue line there, XC. So basically we want that angle between XC in blue and VC in red. And we already know Vx. We worked that out in the earlier part of this question. And we can also work out XC quite easily because we know A to C and X is the midpoint. Okay, so we'll go and work that angle out now. So we'll start by making a quick sketch of the triangle. So that would be V to X, and then if we had something along here, X to C, and then V to C in red, and we want that angle in there. So we'd already worked out in an earlier part, we know that V to X was square root of 29. And we had also worked out that A to C was 5 times root 2. So therefore, X to C is going to be 5 over 2 root 2. Because we know X is the midpoint, so X to C is just half of A to C. So just using Pythagoras, because we know V to X is a right angle, because V was directly above X there. And so just using tan of our angle, so tan theta, well, that's going to equal Vx over xc. So that is root 29 divided by 5 root 2 over 2. And if we want to simplify that a bit, we can get 2 root 29 over 5 root 2. So therefore, theta will equal the inverse tan of 2 root 29 over 5 root 2. You can just put it straight in your calculator like that. That's not a problem. So we'll just go ahead and solve that. So I'll bring the calculator up. So I've got it entered in there already. And we get 56.71 degrees and so on. So therefore theta is equal to 56.71. And to 3 significant figures, we'll leave it at 56.7 degrees. Okay, and that is part C.